Okay, let's dive in. Imagine this. It's September 2023, and you're a seismologist, right? Anywhere on Earth. And you start seeing this really bizarre signal on your equipment,
Hmm.
an ultra low frequency vibration showing up globally, and it just stays
Hmm.
for 9 solid days.
Yeah, 9 days. And then, just to make it weirder, after it faded, it came back about a month later. But
Well,
definitely not your standard earthquake,
yeah.
not an obvious volcano. It was this global hum, a real puzzle.
Right, a puzzle. And the sources we looked at, they actually trace this hum back to one specific, really remote place in this incredible sequence of events. So that's our mission for this deep dive. What was this signal? How on earth did they pinpoint the source? And maybe most importantly, what does it all tell us?
Okay, so let's start with the signal itself. Our sources describe it as a very long period seismic signal, VLP for short,
VLP, so really slow vibrations.
incredibly slow. The sources pinpoint the frequency at 10.88 millihertz. That's,
Hmm.
well, it's way, way slower than the shaking you'd feel from a typical earthquake. It's this deep planetary rumble almost.
Okay, deep planetary rumble. And tracking that led researchers where exactly?
All the way to East Greenland, specifically a place called Dickson Fjord.
Dickson Fjord. In Greenland, that seems unexpected for a signal detected worldwide.
Right. It's not the first place you'd think of.
And the sources mentioned something kicked it off there, something pretty dramatic.
Yeah, they do. The initial trigger seems to have been two big landslides inside the fjord.
Landslides.
And these weren't small slides, big enough to displace a lot of water and actually cause localized tsunamis right there within the fjord.
Okay, landslides, tsunamis in the fjord, that makes local sense. But those are usually, relatively quick events. How does it explain a vibration felt globally for 9 days straight?
Ah, that's the crucial bit. According to the sources, the landslides and tsunamis, they were like striking a bell. They set things in motion. But the real source of that long, persistent hum wasn't the splash itself. It was something called a seiche.
A seiche, explain that, like water sloshing.
Exactly like that. Imagine the fjord as this huge, long bathtub. The tsunamis basically got the water sloshing back and forth, end to end. This standing wave, the seiche, just kept going, resonating.
So wait, the rhythmic sloshing back and forth of this huge amount of water
Yeah.
in one remote fjord, that motion itself created a seismic wave strong enough to travel through the Earth
That's what the evidence points to.
and be picked up by instruments all over the planet. That's kind of mind-blowing.
It is pretty amazing.
How did they confirm it? How did they know it was that specific seiche causing the global hum?
Right, because correlation isn't always causation. But here, the sources say they used satellite data. It was an inference, basically, linking the seismic signal with what they saw from space. And they specifically mentioned using NASA's SWOT satellite mission.
SWOT. Okay, yeah, that makes sense. Surface water and ocean topography. That's its job, right? Measuring water levels.
Precisely. So, with SWOT data, they could literally see the water level oscillating in Dickson Fjord. They could measure the height changes, the timing of the sloshing.
And it matched.
It matched. They could directly correlate the motion of that seiche, its frequency, its timing, with the VLP seismic signal being recorded globally. That was the smoking gun, so to speak.
Okay, let me try and connect the dots here for everyone listening. You have these big landslides in this remote fjord in Greenland.
Yep.
They cause local tsunamis. These tsunamis start this massive, continuous sloshing the seiche inside the fjord.
Mm-hmm.
And that persistent sloshing generates this very specific, very slow seismic vibration.
The 10.88 millihertz signal.
And crucially, satellites like SWOT could actually measure that sloshing, confirming it perfectly matched the timing and frequency of the signal picked up by seismometers worldwide.
You got it. And the sources really emphasize the significance here. This was apparently the first time they could directly observe this whole process, the seiche generating a global signal using satellite altimetry like SWOT.
So it gave them new, direct proof.
Exactly. New insights into this link between what happens with water on the surface, even in remote places, and seismic signals felt across the entire planet. It sort of connects surface water dynamics and deep Earth vibrations in a new way.
Wow. Okay. So wrapping up this deep dive then.
Okay.
We followed this weird global hum all the way back to Dickson Fjord in Greenland.
Quite the journey.
Yeah. Uncovered this chain reaction, landslides, tsunamis, this persistent seiche, and then the satellite confirmation nailing it down.
From a quiet fjord to a planetary pulse.
It really makes you think, doesn't it? Like, why is this story so intriguing for you listening? Does hearing about this change how you view things happening in far-off places? Do you think differently now about how the Earth's water and rock are connected?
It definitely leaves you with something to chew on. Just how interconnected are all these Earth systems, really.
Mm-hmm.
That an event seemingly contained in one fjord can send out these vibrations felt literally around the world. It's a pretty profound thought.